Hello, class CS643. My name is Antonio, and I have with me here Christian. We are group 2, and we are going to be presenting on the paper titled WebPerf Evaluating What-If Scenarios for Cloud-Hosted Web Applications. So the main problem that the researchers were attempting to address with this paper is that developers, particularly new-time developers, first-time developers, and small developers, to go into developing an application for the cloud environment without knowing too much about the different types of cloud configurations that might be out there. So with all the different configurations that exist on Microsoft Azure and AWS, it can be incredibly time-consuming and very costly to figure out what configuration best balances performance versus cost and scalability. So the researchers set out to figure out a way and accurately assess what the user perceived load time would be on different pages given a application's cloud configuration. So this problem is incredibly practical as it specifically targets existing cloud architectures. And in particular, it's a novel issue because previously developers didn't have to consider cloud configuration as an area of latency in their application. They would normally just have to worry about application latency as well as network latency. So given the new novel issue that came up, the researchers really needed to come up with a novel solution. So as far as other solutions being out there, as I mentioned before, this solution specifically targets the cloud latency aspect of total user perceived latency. And other solutions out there don't quite hit the same target. They'll focus more on single page latency or single page performance, or they'll focus on application latency or network latency. The solution out there focuses on the novel problem that the researchers discuss in this paper.
So one of the solutions that is provided, according to a lot of the researchers that have been compiling together, is they to monitor the network latency and the application side and the client side is this WebPerf tool that they've been able to estimate the distribution of the cloud latency upon requests. So they've utilized the WebPerf to implement for the Microsoft Azure cloud service provider, and they've been able to use it for the 6 what-if case scenarios, which will be later discussed in this presentation. And by using it, it provides an explanation for the use case for the solutions, and it makes it a very good appeal for these small-time developers that are in need of efficiency with their time. So given the performance of the application, this WebPerf would be able to assess the distributions in a qualitative perspective, but not so much on a quantitative perspective with the performance. So these developers, they try to use data-driven techniques to provide that rely on the application's historical performance based on the various configurations that the cloud is being put and set through. The build latency models calls in the applications based on the baseline performance, and And then these are some of the required estimations for the cloud latencies to compute the I/O calls as well too. So one of WebPerf's key two insights is one is the causal dependencies for compute and I/O calls. So it has a way of handling the various latencies due to the different traffic controls within the cloud resource. And one of the applications utilizes the task asynchronous paradigm. And to touch on some of the major flavors of the IOs, one of them being the asynchronous programming model, which invokes certain events, which can be completion of an operation, halting of an operation, and so forth. However, one of the drawbacks could be that for developers is that there needs to be a large number of callback to sequence their request pipeline, and this kind of goes into a callback hell problem, which a lot of developers don't seem to like. So the second part of the key insight is the latencies of the I/O call. So to the many cloud resources within the workload parameters, the configurations, and this raises a lot of the challenges where the cloud environment has to have certain specifications, whether it's the storage table size, the geolocation, and then the tiers of the resources, and the profiles, the latency profiles definitely depend on the cloud computing configuration and the workload parameters that are provided. And this brings up a lot of what if scenarios for developers and applications to test on those theoretical assessments. So some of the implementations, a lot of this implementations is very web page focused to optimize. And as I discussed earlier, that this research presentation provides 6 what if scenarios or prototype implementations where they will run the hypothesis to test out these real scenarios in the cloud setting site. So WebPerf will be predicting the cloud side latencies, which it uses a cloud latency prediction algorithm, which is provided within the paper. And then this has been predicted with existing tools like WebProfit as well too, to an end-to-end latency distribution. And then in addition, it also proposes a Monte Carlo simulation-based algorithm to achieve this. So WebPerf, it uses task object ID, thread ID, and async ID to connect all of the settings. So this ensures the correctness from the start to the awaiting time of the different methods, and irrespective of the task completion time. And the network latency is modeled after the RTT between the client's browser and the application front end as well.
So as far as test scenarios go, the researchers looked at 6 different applications, and for each of those 6 applications, they defined 6 different scenarios that those applications would go through. So each scenario modifies some particular aspect of the cloud configuration that hopefully has some sort of impact on the user perceived latency using some of the key metrics that Christian mentioned above. So these 6 scenarios that they created for this first web app was called Social Forum. It's kind of like a Twitter or Facebook clone. And the first scenario is modifying the Redis cache tier from C0 to C2. The second one is modifying the locations of the front end, so having it in US East and Asia East. The next one is modifying the read-write size from and to blob storage. The next one is having other applications interfering or running at the same time as social form. The fifth one, sorry, is a load test, having a sample set of end users all making requests to social form at the same time. And lastly, the sixth scenario was having one of the front end mentioned in scenario 2, having one of those fail and seeing what happens to the latency. So these are just some examples of the test scenarios that they ran through, and they had 6 different scenarios for each specific application.
All right, so to the evaluation of these 6 scenarios that are provided, so we were able to configure and perform the network latency within the milliseconds accomplished within Microsoft Azure. However, this was not done on AWS or Google Cloud Platform, as this was the main focus was for Azure. So in other additions as well too, the WebPerf works within the network complexity. And just going back earlier in the discussions that Antonio has mentioned as well too, is that a lot of these are hypothetical or a novel contribution where there hasn't been an actual like application developed for use for developers to test the network latencies from the client side and from the application side. So and a lot of it, a lot of the details that are said within the paper presentation are accurate. So it's you know, the WebPerf is set out to implement and measure the cloud latencies within the scenarios as accurately and quickly as possible.
So to wrap things up, we're going to take a look at some of the key takeaways that we both shared from reading this paper. So the first was that it told a compelling story in which it took us from point A to point B. Point A being, I'm a developer who doesn't necessarily know too much about cloud architecture, and this is my first time deploying an application. And point B being, now I know what kind of configuration my specific application would best perform under. The next key takeaway that we found was that there really are a lot of variables to consider within cloud latency. And specifically in the paper, they looked at just Microsoft Azure cloud configurations, but looking at Amazon Web Services, the problem just is compounded with all the different types of scenarios that developers can come up with in order to tailor to their specific user needs. So really, WebPerf, it outshines itself, specifically with Microsoft Azure, but we would like to see how WebPerf would perform with Amazon Web Services as well. And finally, we looked at the benefit that WebPerf provides to developers in that they don't have to spend a lot of time or developer resources in order to make sure that their users are having a good experience based off of the first launch, and that they don't have to test around too much with different cloud configurations in order to tweak it and find it correctly, especially for developers who are first dipping their toes into cloud computing and applications hosted in that kind of environment. Thank you.
Thank you. If you guys have any questions, concerns, and suggestions, please leave them below in the reply section so that we can have further discussions. Thank you.